All right, hey. So this is going to be log equations part 1. There's going to be 2 parts to this. So the day 4 notes are part 1. All right, so we're going to have to solve equations now. Before we were just practicing with the properties, converting logs back and forth, stuff like that. But now we're actually solving them for a variable. So there's 3 basic types, and the first one we're going to go to is if you see one log on both sides, only log one time on both sides. It is important that these bases match. They're usually going to match, but when they don't, we'll get to that in a little while. But when they match, all you have to do, this is the easy kind, all right? You cross them off, and then you solve what's left over. If there's nothing left to solve, you're finished. So this right here is called basic, the basic types. When you just have a log equal to a log, all you do is cancel the logs and solve, okay? So these are the easy ones when log is on both sides, all right? Kinsler, can you do that some other time? All right, so over here you look, log on both sides, you cross it off, and you solve whatever you see remaining, okay? So then if I solve this one, I'm gonna subtract 2, I get 2, add 3x to the other side, divide by 4, so you get x equals 1/2. Okay. One thing that's important, if you are to plug this back in up here, you shouldn't end up with a negative after the word log. If that ever happens, the solution isn't able to be used. It's called extraneous. This one, if you plug a 1/2 in right here, that's still positive. And if you plug a 1/2 in right there, that's positive. So the solution is good. You do need to check logs, okay? All right, let's try this one. This says x squared plus 4 equals 29. Remember, ln and log, they're kind of interchangeable. They're not exactly the same, but they have the same properties. So we can cross them off because they're the same on both sides. So now we have this problem. X squared plus 4 equals 29. Now all we have to do is solve it. So solving an equation with log on both sides is just like solving equations that you've known how to do for years now, okay? So x squared equals subtract 4, square root both sides, x equals, and nobody was gonna forget that, right? When you solve by taking the square root, you put plus or minus. So x equals plus or minus 5. You plug 5 in there, that's positive. If you plug negative 5 in there and you square it, you also get a positive 25. So both of these answers work. So you do need to check to make sure that you don't get something that would turn it out to be negative, okay? All right, and then this one, again, if you ever see log on both sides, they match up perfectly. Those are the best kind. Those are the easiest problems to solve. So now you just solve what's left over. X plus 1 over 3x minus 2 equals 2. Now we need to solve this problem. So you could multiply both sides by the denominator. So if you multiply this over here, I would have x plus 1 equals 2 times 3x minus 2, which is 6x minus 4. If I subtract x, I get 5x. Add 4 to the other side, you get 5. Divide both sides by 5, and you get x equals 1. All right? If I plug 1 up here, I get a positive everywhere, so that answer works. All right, so that's the easy type. If you see the word log on both sides of the equation, you just cross it off and solve what's left over. Easy, okay? Kinsler, please stop. All right, so then you come to the next one. No. All right, the problem with this one is you've got 2 logs on this side and only 1 log on that side. You are not allowed to cross off 2 over here and 1 over here. It doesn't work that way. You can only cross them off if there's 1 on each side. So what we're gonna have to do is condense. That's what we learned in the last video in the properties thing. It's where we condensed it down. We can turn this side over here to 1 single log. So what you're gonna do is gonna be log base 3. Subtraction, remember, turns into division. The 5x plus 13 goes on top. The 6 goes on the bottom. So I've condensed this side over here down to 1 log. So that's the point of learning the properties, is so that you can switch from an expanded form to a condensed form. Now that I have this on one side, I can leave this side alone. Once you condense whichever side you need to condense, it turns into the problems at the top. We can cross out the logs that match and solve what's left over. So I would get 5x plus 13, multiply over here, equals 18x. If I subtract this, I get 13 equals 13x, therefore x equals 1. And again, you do need to check. If you plug 1 into this entire thing up here, you have to go back to the very original and check it. If I plug a 1 in right there, I don't get a negative number. There's no x to plug it in for here. If I plug in a 1 right there, I don't get a negative. If you ever get a negative when you plug your answer back in, you can't use it, okay? That'll probably happen in a minute. All right, so you look at this problem. We can't cross out the LNs because there's 3 of them. You can only cross off 1 on each side. So we've got to take this side over here and condense it down. So this, remember, you write ln 1 time. Where does this 2 go? Remember, it must have been the exponent. So that's ln of x squared times 3 equals ln of 27. Okay? So I can cross those out. Now they're the same. 1 ln on each side. This right here, x squared times 3, I usually write it as 3x squared. Now you solve your problem. Divide both sides by 3. X squared equals 9. X equals, everyone was going to put plus or minus, right? Because you have to square root both sides, you get plus or minus 3. Again, you have to check. This is 2 different answers, so we need to check. If I put a 3 in right here, I'm good. I'm taking the ln of a 3. That works. If you take the negative 3 answer, though, and you plug it in right here, this says 2 ln of negative 3. You cannot take the log or natural log of a negative number. That means we can't use the negative. That one doesn't work. So my only answer that works is 3. Negative 3 right here is called an extraneous. An extraneous solution is one that you get whenever you're working it out, but if you try it back in the original problem, it doesn't work, okay? Because we can't take the log of a negative number. So the only correct answer to this one is 3. So on your math lab, if you're solving these and you get it wrong, it might be that you're leaving extraneous solutions in there. So watch out for that, all right? Okay, let's go down here. We look at this one. We have 2 logs on this side and only 1 log on that side. So before we can do anything else, we have to condense this side over here. Whenever you condense, you have 1 log. So it's log with a little 6. Again, it's a subtraction. Subtraction when you're condensing turns into division. So we put 3x plus 14 over 5. So this goes to the top, this one goes to the bottom. This one, log base 6 of 2x. We have log on both sides, we cross them off. So now we're solving this problem. Once you get it to here, it's pretty easy. So I would have 3x plus 14 multiply equals 10x. 14, if I subtract 3x, I would get 7x. So then I would get x equals 2. Again, check. You plug 2 in right here. You don't have to check to see if it works. It should work. You just have to make sure it doesn't turn out negative. So if I plug in 2 right here, I get a positive number. If I plug in 2 right here, I also get a positive number. So this answer is okay. You're just checking to make sure you don't get a negative. All right. And then this last one. Oh, this is good. There's log on both sides, only 1 log on each side, so I can go ahead straight to crossing it out. I don't have to do anything special. But now I've got to set these equal to each other. So t squared minus 6 equals t. I can't just solve this by combining like terms. So what do you have to do whenever it's quadratic? You need to factor. So I'm going to move this t over here. Remember, you always want to make it equal to 0. And then hopefully this one factors. If it doesn't factor, we're going to have to do the quadratic formula. But let's see if it hopefully factors. Anything multiply to make -6, combine to make -1? I think so. T minus 3, t minus t plus 2. So our answers would be 3 and -2. Before we move on, we've got to make sure. If I plug 3 up here, is it going to be positive here? Yes. Positive here? Yes, that one works. -2, right off the bat, I see right here, if I plug a -2 in for that t, I'm now taking log of -2, which is not allowed. -2, that one's extraneous. You don't have to tell me it's extraneous, unless like on the math lab, if they say, are there any extraneous solutions, you would put -2. But the answer to this problem is only 3. Okay? So all of this page is basic, just solve equations as long as you can get it condensed down to 1 log on each side, and then you cross them off and you solve like normal. So you don't have to have any fancy logarithm rules for this page other than condensing them down. Okay? All right, we're gonna move on to the next. This one's a long problem, but we're just gonna follow all the steps. What you see on this one is that you've got to condense both sides. There's 2 logs over here, and there's 2 logs over here. You can't just cross them all out. You've got to condense both sides first. So you have to condense both sides. So that means write each side as a single logarithm. So this is log base A. You look right here. Since that's a minus, it's going to be divide. If this had been a plus, it would have been multiply. So I put x minus 1 over x plus 6. This side, you write log A down 1 time. Again, it's a subtraction, so we divide x minus 2 over x plus 3. So when you first look at this problem, it looks like it's going to be really complicated because you see the word log a whole bunch of times. You just condense each side down to where you only have 1 log. Once you only get 1 log, you can cross those off, and now you have a regular algebra problem. Now this one's not the easiest because you're going to have to cross multiply because you have this now. So the way you solve a proportion is butterfly or cross multiply like that. So you do have to FOIL. All right. So I'm going to kind of do part of this in my head, but I know if you need to, go over to the side and write it down and FOIL it. Okay. This one's going to turn out to be x squared minus 2x plus 6x. So that'll be plus 2x. And then, sorry, plus, maybe I need to write it down. So x squared minus 2x plus 6x, this is going to be 4x, sorry. Plus 4x minus 12, that's a 4. And then this one, whenever you FOIL it, is going to be x squared plus 3x minus 1x, that's the 2x, minus 3. So I have x squared plus 4x minus 12 when I FOIL these two. X squared plus 2x minus 3 when I FOIL those two. Now we get everything on one side. X squared moved over here is going to end up canceling those out. If I move this 2x over here, 4x minus 2x, I'm going to be left with 2x. If I add 12 to this side, I'm going to get 9. So now I'm to here, 2x equals 9. So x equals 9/2. And again, you do need to check and make sure if you plug in 9/2 here, that's bigger than 1. That's good. That's positive. That's going to work too, and that's going to work. So that one works out. There's no extraneous, and that is your answer. All right. So the main difference of this one, whenever you see a lot of logs in a problem, you just have to condense every side down. Okay. All right. And now we have the last type that we're going to do in this lesson is where we have a log only on one side. All right. If there's log on both sides, remember, you just cross them off. That's easy. But if there's log on both sides, log only on one side, what you have to do, remember the thing we did last day, the last day of notes was swoop. What we have to do is rewrite it in exponential form. Okay, so I've got to take this and turn it into an exponential. All right, the way that we did that is we took the base, and we haven't talked about this yet, but we need to. If you have a log and there's no little base number down here, logs are always base 10, unless they give you a different log. Write that over on the side somewhere, or if you're not writing this down, remember it. Log has a little bitty 10 down there if it doesn't give you a different number. ln, the natural log, always has a base of e. This is very, very important, okay? If no base is given after the ln or the log, it's always e for ln and 10 for log, okay? So on this problem up here, I see the word log with no base behind it. You have to put the 10 there. And remember, the way that you swoop this is you go from here to here to here. Okay, you turn it into a little e. So rewrite this as 10 to the negative 2 power equals x. Okay, 10 to the negative 2 equals x. Once you get it written like this, you can solve this. We practiced this earlier in this chapter. 10 to the negative 2 is the same thing as 1 over 10 squared, which means 1 over 100 is our answer. Okay. All right. So this one, our base, ln of x equals negative 8. Again, I can't just cross this off. The only time you're allowed to cross it off is if there's a log on both sides or an ln on both sides. So I say there's nothing down here, so I add the little e, and then I swoop. You swoop it like this, okay? E to the negative 8 power equals x. This to that equals whatever's right there, okay? So this 10 to the negative 2 equals x, e to the negative 8 equals x. So that's my answer. You can't really solve that. Remember, e is just a number. A better way to write this would be 1 over e to the 8. Because typically we don't leave negative exponents in our answer. We rewrite them like this. Okay. Here, we don't want to do anything with this. We want to get the log by itself first. So you have to say, okay, this 6 is in the way. How could I get this 6 to the other side? Well, it's being added, so you could just subtract it and turn it into this problem. 3 ln of x equals negative 2. So think, I need to solve this equation. I want to get ln of x by itself. So I can take this 3 and divide both sides by 3. So now I have this problem. ln of x equals negative 2/3. I'm not finished. You're not finished with the problem until the x is by itself. So put your little base down here. It's an ln, not a log. That means my base is e. And then swoop it. So e to the negative 2/3 equals x. All right. This answer is technically correct, but we don't like to leave negatives in there, and we don't really like to leave fraction exponents. Remember, negative exponent, this problem right here, is going to turn into 1 over e to the 2/3. Instead of writing e to the 2/3, I can do that. Remember, this is the same thing as e to the 2/3. The negative dropped it to the bottom of the fraction. The 2/3 became the cube root of e squared. So this would be the best way to leave your answer. Okay. All right, so again, when you only have log on one side of the equation, you want to swoop it. You want to turn it into an exponential problem and then solve from there. Okay. All right, 3 more. Look at this one. So I'm trying to get the log by itself. So the first thing that I want to do is divide both sides by 3 to get that 3 out of there. So now I have this log base 4 of 6x, and this should really be like that. Okay, anytime it's right after the log, that means it must be connected, so it kind of makes more sense to put it in parentheses. Okay, now I have log on one side, I'm going to swoop. So I start with the base, and I say 4 to the third equals that. You swoop it like this, make an E here. Start with the base and go around like that in a circle. 4 to the third equals 6x. Then you just solve that equation. So 4 to the third is 64. Divide both sides by 6. 64 6 is the same thing as 32 thirds, and you could just leave your answer like that, or if it says round to the nearest whatever, you could get a decimal. Okay. All right, look at letter E. We only have log on one side, but we have 2 logs on one side. So before you can do anything else, you have to condense. Okay? Because I can't do the swoop thing until I have log only have 1 log on each side. So I'm going to write this log, a plus in between 2 logs turns it into multiply. So this is the same thing as x times x minus 9 equals 1. So I'm not doing the swoop step yet. I'm just condensing it down to a single log. Okay. There's a couple things that we need to fix on this. Whenever I don't have a little number down here, and it's a log, remember log has a base of 10 if no base is given. ln has a base of e, log has a base of 10. Okay. So now I can swoop. 10 to the first power equals this, x times x minus 9. So 10 equals x squared minus 9x. And we do have to solve this equation. So I'm going to move the 10 over. X squared minus 9x minus 10 equals 0. Factor. X minus 10, x plus 1. So x is 10 and x is negative 1. Okay? You're finished as long as neither one of these are extraneous. Don't forget to check. Okay? I don't think I checked on the last one, but I knew that it was going to turn out positive if I plugged in a positive number. All right, so here, if I plug in a 10 here and a 10 here, I'm okay. But if I plug in a negative 1 right here, I see that I'm taking the log of negative 1, which is not allowed. You can't take the log of a negative, so the only answer is 10. Negative 1, remember, is an extraneous solution. Okay? All right, one more. Okay? So the first thing that you're going to want to do is we see 2 logs on the same side. So what we want to do is condense first, just like we did on this problem. I see a plus sign. Remember, plus turns into multiply when you're condensing. So I have log base 4 of x plus 3 times 2 minus x equals 1. Now I've gotten it down to a single log. As long as you only have 1 log on each side, you can swoop. So I'm going to swoop the 4. 4 to the first power equals this. Okay? I'm going to go ahead right now, instead of writing it down, I'm going to go ahead and FOIL this out. This FOILs out to 2x minus x squared plus 6 minus 3x. So I have this 4 to the first equals all of this. So now I just rewrote it. 4 to the first equals, this is that FOILed out. So now I need to combine like terms. What's this going to be? Negative x squared minus x plus 6. All right, so let's move everything over to one side. I'm going to move this over here so I don't have a negative exponent. I'm going to move all this way. X squared plus x. And if I subtract 6 over here, I have minus 2. Okay, so all I did in this step is I moved everything over to the left side. So it changed some of the signs. So I got to here. Once you get here, you check to see if it factors, and if it does, you factor. If it doesn't, you have to do the quadratic formula. But luckily, this one does factor. X plus 2, x minus 1. So I get x is negative 2, and I get x is positive 1. We need to check to see that they both work, okay? If I plug negative 2 in up here, that ends up being still a positive 1. Negative 2 plus 3 is still positive, so that's okay. If I plug negative 2 into that one, I still get a positive. So negative 2 does work. So I don't want you to think that every time you get a negative answer that it's extraneous. It doesn't have to be extraneous. It could still work, all right? If I plug 1 up here, I get a positive answer. If I plug 1 up here, I get a positive answer. So both of these answers work. So you don't have to get an extraneous solution. Sometimes every answer that you get works. Positive answers work, negative answers work. You just always have to check by plugging them back into the problem, okay? After you finish this set of notes, you should be able to take the Canvas quiz that's supposed to be done like in week 2 of this unit. But you should have learned all the stuff that's going to be on that Canvas quiz. So you can go ahead and take your Canvas quiz. All right, thank you.